Have you ever looked up at the night sky and noticed the moon is just gone? Or maybe you've seen it do that incredible disappearing act where it turns a spooky red. Well, we're going to solve a really common celestial mystery. What is the difference between a new moon and a lunar eclipse?
On the surface, it seems pretty simple, right? A dark moon is a dark moon. What's the big deal? But the truth is, the reasons why it's dark are completely different. One is just a normal, monthly thing. And the other is a rare and spectacular cosmic event. So, what is actually going on up there?
Okay, to figure this out, we first need to introduce the main players in this little drama: the sun, the earth, and our moon. The best way to think about them as celestial dance partners, always moving in this beautiful, predictable rhythm.
So, first up is our home base, Earth. We're on this massive year-long journey around the sun. You can think of this huge orbit as the dance floor, where all the action happens.
And while that's happening, the moon is doing its own little dance, circling around us, the Earth. This loop is way faster. It takes about 29.5 days, and that constant motion is exactly what gives us the familiar phases of the moon we see every month.
Right, so let's talk about that rhythm. The phases of the moon aren't special one-off events. They're just the totally natural, predictable result of our changing point of view. As the moon orbits us, we see different amounts of its sunny side. That's all it is.
And this cycle is as regular as a heartbeat. It always starts with the new moon, where it's basically invisible. Then it grows, or waxes, to a big, bright, full moon. And from there, it shrinks, or wanes, all the way back to dark, ready to start the whole thing over again, every single month.
So, the new moon is all about position. It happens when the moon is sandwiched right between the Earth and the sun. So the side of the moon that's all lit up by the sun, it's facing away from us. We're left looking at its dark side, which is why it just disappears from our sky. It's a totally normal, predictable phase. But then, every once in a while, something different happens, something way more dramatic. This is where the plot twist comes in: eclipses. See, an eclipse is not a phase. It's a special event where a shadow literally steals the show. In a lunar eclipse, the Earth moves directly between the sun and a full moon. When that perfect alignment happens, our own planet casts this enormous shadow that stretches out into space and falls right onto the moon, making it go dark. So it's not about which side is lit, it's about the moon being completely covered by Earth's shadow.
All right, we've got our two big ideas, a phase versus a shadow. Let's put them side by side and solve this dark moon mystery once and for all.
And first, let's be honest, it's easy to see why this is confusing. From down here on Earth, a dark moon is a dark moon, but the reason is what matters. With a new moon, the light is still hitting the moon, we just can't see that side. With a lunar eclipse, the light is being physically blocked by our own planet's shadow. And wow, when you lay it all out like this, the differences are just huge. The cause? Simple geometry versus an actual shadow. The phase? Well, a new moon happens during the new moon phase, but get this, a lunar eclipse can only happen during a full moon. One is a routine monthly thing, the other is a rare event, only a few times a year if we're lucky. And the look? One is completely invisible, the other is a stunning show where the moon darkens and often glows this incredible coppery red.
Okay, but this brings up a really good question, doesn't it? If the moon is between the Earth and sun every month for a new moon, and the Earth is in the middle for a full moon, the alignment seems to be there. So why don't we get eclipses every single time?
The whole answer, the entire reason eclipses are so special, comes down to this one single number: 5 degrees. That's it. This tiny little tilt changes everything.
So that 5 degrees, that's the final piece of our puzzle. The moon's orbit around us isn't perfectly flat. It's tilted by about 5 degrees compared to Earth's orbit around the sun. Because of that tilt, most of the time, the moon passes just a little bit above or a little bit below Earth's shadow. An eclipse only happens on those few, rare occasions when the full moon's path crosses our orbital plane at the exact same time. The alignment has to be absolutely perfect. And that just doesn't happen very often.
So if you take away just one thing from all this, let it be this. A new moon is a predictable, monthly event all about orbital geometry. A lunar eclipse is a rare, special event all about planetary shadows.
You see, in the end, it really is a celestial dance. Sure, every eclipse is tied to a specific moon phase, but almost every phase just comes and goes as part of the normal monthly routine.
It's that tiny 5-degree tilt that makes all the difference, separating the everyday rhythm of the cosmos from those rare, revolutionary moments that make us all stop what we're doing and just look up.